So starting broad, we want to say, what do we mean unexpected startups, right? Like, what does that mean? So starting with, you think about a piece of machinery that is starting up in a time that A is unexpected, and also B is likely to cause some kind of energy or even just to present a hazard. So there's obvious kind of conditions on when a machine restarting would be hazardous, like somebody has their arm in a machine doing maintenance, or someone is, let's say, grabbing a work piece or is very close to the point of operation. But there's also some more kind of subtle things. For example, that if a piece of debris or a work piece or a jacket is sitting on a machine when it starts, if anyone's ever seen that on a table saw, it basically turns into a catapult. And so thinking about like all these kind of bad things that can happen when things restart. And I remember the time at airports before there was alarms for the baggage carousels. I remember as a kid, very specifically, that I was playing basically on the carousel when it started, and it scared me to death. And I remember I had my sweater around my waist, and one of the drawstrings got caught between the two little slats. Only happened for about half a second. It pulled out right away. I was fine, but it scared me to death. And of course, now they have big alarms and lights that go off before that carousel starts moving because it's such an obvious hazard. But when we think about most of our equipment, there are a lot of ways it can restart itself. And going over to the left there on the causes, one is just straight up, you accidentally press a button or you have an unprotected foot switch, right? The actual person using the machine makes a mistake and turns it on by accident, or they reset it when they would not expect it to restart. One good example is that in an emergency stop situation, one of the ANSI requirements is that when you reset an emergency stop, that a separate and intentional action is required to start the machine after a reset. So as we're going through that, another way is that in the there's kind of someone else is turning the machine on, whether whether they're aware of the person in that room or not. And so when we think about that, that's often someone in a breaker room, right? Something that will, for example, let's say you trip a circuit breaker and the person in the breaker room will go ahead and flip that breaker on, not knowing that someone downstream is using a machine. Other kinds of things that would make a machine start up are if there is a thermal protection device that resets automatically. For example, a lot of lower end motors have a thermal device in them that is very similar to that thing you stick in your turkey. You know, it's Thanksgiving time, you got that little thermal device that pops out at a certain temperature. A lot of lower end motors will have a device like that, but unlike your turkey, when the temperature then drops, that will reset, right? And in the event that you have not planned for that in your machine guarding, power would be restored to the motor. And so this is just one of those many things that can come up and be a problem. So I see something from the chat. So Doug is saying that he would actually disagree with the manual reset of emergency stop because emergency stop function only permits restarting. It doesn't cause a restart. So to Doug's question, absolutely true. And what I'm trying to show by this slide is that there's just this world of ways the machine can restart. But if you designed machine guarding right, it won't, which we're going to get into in just a sec. So Doug, I think we're on the same page, and I'll get there in just a moment. The other thing that we're going to be talking about specifically today is when we're thinking about restarting after a loss of power. So that basically means, imagine you've got your machine, it is in the on position, and you lose power for some reason. When power is restored, that is still in the on position, and it will start. Now, you would assume that most tools would be designed to not do that, when in fact, almost all of them are. So we're going to be diving into a little bit of what Doug mentioned now. And here we go. Oh, excuse me, almost there. So also, when we're talking about machinery, we do literally mean all machinery. And so again, we're talking specifically about electrical today, and specifically about motors, which is a subset of the kinds of restart. But we can obviously think about power tools and machine tools, but also conveyors, rollers, mixing equipment, really anything that has an electric motor. And so that really kind of expands this scope tremendously. You think about, like, this is everything that has a motor. Like that is, and there is clarification in the regulation that says if the restart is likely to cause a hazard, or if the restart could be hazardous. And so when we're thinking about this, and you look at that mixer, for example, in the center of the frame, I would argue that no matter what, that starting unexpectedly would be hazardous. Now, if you have a fully enclosed device that uses a motor and there's no way for someone to get in there and get hurt, you could very reasonably argue, and hopefully document with a risk assessment, that there isn't a hazard from that restarting, in which case this wouldn't be required. But as you know, you really have to be able to put your foot down and document that you've done that thinking. So now diving into what Doug was mentioning. So I talked about all those different ways a machine could restart, right? So all the ways that it might. Now, there are lots of regulations that control most of those. And the thing that gets hard for people is that they all overlap, and those overlaps aren't always obvious. So on the right here, in this kind of green area, and let me see if I can highlight this for us really quick. Hopefully you guys can see this little laser pointer. So this green area over here is when you're doing some kind of intentional maintenance, right? You're servicing a machine. This is your lockout tagout territory, right? So a huge part of the hazardous energy control, right, is making sure that hazardous energy, like a restart, doesn't happen when you are disposed, when you have bypassed guards, or when you're maintaining equipment. So hazardous energy control and these various standards govern and protect people here, right? So this is all lockout tagout territory. We're not diving into that today, but that is where that should be. On the other hand, as Doug was mentioning, is normal machine guarding requirements. This is where things exist, like when you reset an e-stop, the machine should not restart without an intentional and deliberate action, right? So if you're following existing machine guarding regulations, that's already covered, right? And again, that can be a whole webinar in and of itself. So Doug, I hope that kind of gets to your question. Then there's this middle area. So this middle area is a little bit of what we're talking about today. So there's intentional production, there's intentional maintenance, there's also this strange little minor servicing exception that is its own webinar that we could talk about at another time. But in these unplanned things, right, the Murphy's Law, when things are happening that we didn't plan for, whether it's straight up human error, whether it's a defect in a material that you hit, there's a nail you didn't expect in a piece of raw material, or that there is an under voltage event from the utility, all these different things. And this is where we're going to focus. So in these, some of these are pretty clearly covered by machine guarding. Some of them should theoretically be installed by the people physically installing electrical infrastructure. Because you can see when we get into this kind of under voltage, loss of power stuff, which is our focus today, yes, it's under machine guarding, but it's often overlooked. It is regulated by nationally recognized test labs, where they regulate the equipment you would use. And the different electrical codes also require that to happen. Problem is, as I mentioned earlier with the with how Cal OSHA is currently written, is all these things are not mentioned in the machine guarding standards. They're mentioned in the electrical standards. And that, for me, makes it very unclear because, as I mentioned earlier, a safety professional is going to read the machine guarding sections. They're not going to be digging through all of that. And so Risk control in the chat asked a question. They said, where would removing a jam be in this schematic? So in this schematic, right, which is one of our creations, removing a jam, this is where it gets gray. Some would argue that that would be if a jam was, quote, routine, repetitive, and integral to your process. Someone could argue that that's part of your minor servicing exception in normal production, in which case your machine guarding would theoretically protect you. However, if you had to bypass a guard to do this, a case could be made that that is then service and maintenance, in which case you need to do lockout and tagout. So that it gets very gray. Doug is offering right now in the chat that the over and under voltage requirements are in the NFPA 79. Yeah, so if you look on the bottom here in electrical, fire, and safety, we do call out NFPA 79 is a part of that. Definitely used by control systems engineers. And where we're going to be kind of living today is in the area where if you have a large control system that was intentionally designed by a control systems company, all the things we're talking about are things you know. What we'll be focusing on today is the things where you're using equipment that doesn't have that. And you're in this spot where you might have a piece of equipment that turns on and off, like so many of us do. When I walk into a facility, there is the large equipment with industrial controls, and we'll be talking through all those things. But then there's also the little bandsaw in the corner and the conveyor that only gets used at Christmas, and all these other things that don't have large, elaborate controls. And so what we'll be talking about today is not the perfect thing that could cover everything, but some low-hanging fruit you could do that will help out and could prevent injuries.